Section 5.2 Venn diagrams. Before I start the Venn diagrams, I'll just revise about this topic. So first of all, let's start with set. What is set? Set is a collection of set is a collection of objects. So we symbolically we put this bracket to represent the set. Elements or members. Objects or those objects in the set refer as element or members. I define a set 2, 4, 6, 8. I name this set as A. So 2 is a member of or element of A. 4 is a element or member of A. 5 is not the element or member of A. So this is the sign for member or element. Equal set. Both set have exactly the same elements. For example, I'm defining a set odd, odd numbers between 3 and 8. So what is this set? 3, 4, 5, 6, 7, 8. So it between 3 and set odd numbers 5 and 7. 5 and 7. What is NA? Number of element 2. So here NA is 1, 2, 3, 4, 4. C. Prime numbers between 3 and 8. What are the prime number between 3 and 8? Still 5 and 7. So NB equal to, we don't need this one actually. So both have the same element. Hence B and C are equal sets. And empty set. So we have to define a set, but there is no elements. People whose height more than 2.5 meters. Can you find the people? This is well defined because we can measure this set. Set also define countable and uncountable sets. So we don't work on uncountable. We are working on countable sets. So it is clearly distinguished that the people whose height is more than 2.5 meters, you can't find any. So this is a empty set. We write like this, or we write like pi symbol. So we do set element or members equal set and empty set. Then subset. I'll define a set A. 2, 4, 6, 8. I define another set B. 2 and 4. Now we can tell that B is a subset of A. We write in B is a subset of A. So this is the symbol we use. It means, what is B is a subset of A? What is the definition? All the elements in B in A. Can you see all the elements in B, 2 and 4 in A? And A is bigger than this. So B is a subset of A. So NA equal 4, NB equal 2. Number of element 1, 2. Just for the, so this is subset. So we can show as a Venn diagram. So this is A and this is B. So this is going to be 2, 4, and the rest of 1 is going 6 and 8. Now we can draw set A. 2, 4, 6, 8. Then what is not A? And this is the issue. To avoid this one, we define a universal set. So this is the universal set. All the stuff, this set, we show by a square, and this is the symbol. So this set is called universal set. So this is the set. Set contain all the elements relevant to particular problem. We show like in a box, and the symbol is epsilon. So I'll define a universal set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A is 2, 4, 6, 8. B is 2, 4. So B is a subset of A. So then we can mark, show that like this. So this is A, this is B, and 2, 4, 6, 8, and all other. So this is A, this is a subset B inside, and all other elements should be marked the outer area. So this is A. So 1, 2 here, 3 no, 4 here, 5, 6 here, 7 no, 8 here, 9 and 10. So what is this area called now? So that is where the complement comes. So B is 2 and 4. Now this area called complement. Complement. Idea is not belong to. So A complement means not belong to A. So I'll stay with this one without B. So now this is A. What are the elements of A? 2, 4, 6, 8. And A complement is not belongs to A. Not belongs to A. So what are is the complement? 1, 3, 5, 7, 9, 10. So this is A. This is A elements. This is A complements element. It means not belongs to A. So this is the area. We draw like this. If this is A, so this is A complement. So this is the area A complement. Sometimes it is also show that in this symbol A dash as well. This is very important. Write the set of letters in London. Letters used to write word London. So if so LONDON, this is wrong. We can't repeat LOND. So no repetitions. This is an important rule when you write elements. So there should not be two same element in a set. I can see here two O's, we have to take one O. I can see here two N, we have to take one N. So other one is intersection. Assume set A have 2, 4, 6, 8, 10, and set B have 2, 4, 7, and let's get the F side and universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can write now, we can show. So this is A, this is B, and I can see 2, 4 commands or 2, 4 is here. Then what is A? 6, 8, 10, then 6, 8, 10 here, and then B. 2, 4 here, 7 is here. Now anything else goes to other one. 1 here, 2 here, 3 is missing, 4, 5 is missing, 6 here, 7 here, 8 here, 9 is missing, and 10 is there. So now I did. Now NA is 1, 2, 3, 4, 5. NB is 3, 1, 2, 3. N is number of element in it is 10. And so intersection. So this area we refer as A intersect B. A intersection B. A. So this is the symbol. So this is the intersection symbol. Now, what is the element of A intersection B? 2 and 4. What is N A intersection B? That is 2. There are 2 elements. What is A complement? A complement means not belongs to A. So this is A, not belongs to A, 1, 7, 1, 3, 7, 5, 9. 1, 3, 7, 5, 7, 9. Anything in the A we can't take. So in A complement means 2, 1, 2, 3, 4, 5. There are 5 elements. What is B complement? Not belongs to B. Then they find the B and don't include that element. So don't include 2, 4, 7. So 1, 3, 5, 6, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. Yeah, 7 plus 3, 10. Right. Okay, that's fine. And B complement C is and B complement C is 7. What is A intersection B complement? What are the elements? First of all, select where the A intersection B and not belongs to A intersection B. Apart from 2, 4, you want to write everything. 1, 2 inside, so 3, 4 inside we can't take. Then 5, 6, 7, 8, 9, 10. All the elements without 2 and 4 because not belongs to intersection part. So in A intersection B complement is going to be 8. When 1, 2, 3, 4, 5, 6, 7, 8. Intersection usually we identify like this. When we have this is a universal set. This is A, this is B, A and B. We can use 2 patterns to mark A. So we are going to find A intersection B. You may need this knowledge. So we mark A. Then we mark B with a different pattern. Now you have to pick up the area where both pattern exist. Now both pattern you can see like this one. So only this area you can see A intersection B. That's how you want to find a intersection. You can figure it out the intersection. So I'll ask another question. Find A complement intersection B. So you can give a try now. before. This is A, this is B. Now A complement intersection B. What is the area now? Uh, so mark with A complement with different pattern. One pattern. So this is A, not belongs to A. This is, can you see now? I only left A because A complement mean non belongs to A. I mark the A area. Then I will mark with different color or different pattern the B. So B is this. Now where you can see both. So you can see both. So we mark like this one, other one is here. So both symbol is where you can see. This is the area you can see both symbol. So it means I will color this one. So this is A complement intersection B. If I ask to write uh, B complement intersection A, this is also same. B complement intersection A complement, still the same. Or A intersection B complement, both same. Then what is that area? This is the area. B complement not belongs to A intersect with A. So this is the area. B complement intersection A. So if you are in trouble that can't find what is the intersection area, what you need to do, you have to use two patterns to uh, draw this one and select the pattern where you can see both. Select the area uh, the where you can see both pattern. Now the other one is union. Union mean this is the informal idea is addition. What happens when you add A plus B? So we write like this: A union B. So this is the symbol for union. This is symbol for intersection. So it means you need to have the elements belongs to both A and B. So what are the elements belong to both A and B? 2, 4, 6, 8, 10 and 2, 4, 7. Now this, if you write 2, 4, 6, 8, 10 and 2, 4, 7, this is wrong. Can you remember London example? A union B. You can't write two together, only one 2 and only one 4. So the answer is 2, 4, 6, 7, 8, 10. This is the right answer. So N A union B. So without looking this one, can you find from here? So 1, 2, 3, 4, 5 and 6. You can write take this one. So it is 6. Now what is the A union B complement. So A union B complement. So A union B. So this is A union B and complement not belongs to it, either not A or B, neither not A or no B. So then that has to be 1 3 5 9. 1 3 5 9 not belongs to A and B. So N A union B complement is 1 2 3 4 4. How do you draw A union B? So assume this is A and this is A, this is B. So you have what you have to do. You have to take, if you select a pattern, so mark with A that pattern and then continue with that to B. We don't take two patterns. That's how you usually symbolize union in a drawing. You really need this knowledge when you come to the second year. There is a topic. So I'm going to write the same thing over there. Now this is ABC. So that is the Venn diagram. And my question is, write the element of A union B dash or B complement intersection C. How do you find this? Now you can do that one if you are not sure. First of all, find what we have the A union B dash. Oh, so this is a union. We are using same. So A. So this is A. This is B, and this is C. So we will color this one A union B dash. So not belongs to B. We need A area and area not belongs to B. The argument is same same pattern. So you can see only this bit is remaining now. Now I want to intersection C. So I have to take different pattern. So intersect with C. Then I have to use. So what is C? I'll mark C. Then I can only see this is the area it has common. Basically we need this area. So from here this bit. The picture is not that clear. I will draw again. So this is A, B, C, then A union B dash. So A and continue with B dash, not belongs to A. So this whole area. And it's going to be an intersection now. This is A. So it's going to be an intersection with C. So then we'll take different pattern because it is an intersection. We'll mark C now. Now where you can see both pattern. So you can see both pattern in here, in the middle. I missed this part. Now it's clear. And this one. And this part. And this one. Basically D, F, and E. Now we'll work differently. What is A? A is C, D, H, F. C, D, H, C, D, H, F. What is B dash? B dash going to be not belongs to B. So A, B, C, D, E, A, B, C, D, E. That's all. Now A union B dash. Now you can add. This is going to be addition, but we have to avoid the repetition. So what are the repetition? Any repetitions here? D is 2 times, and that's all I can see. Yeah, C is 2 times. Yeah, so we'll start writing A, B, C1, D1, E1, and H and F. Now you can write C. What is C? D, this is C. So E, D, E, F, G. D, E, F, G. Now I need intersection of both. What is the meaning of intersection? Intersection means common element uh, belongs to both. What are the common elements? Intersection means common elements. So A not common. Yeah, D is common. Then F is common. And E is common. Any other commons? D, E, F, no G, and apart from that, that's all. Now we will derive a formula. A, B, C, D, E, F, G. Now, what is A set? A is B, C, D, E. You can see from there. B is D, E, F, G. What is NE? NA is 4. NB also 4. Now what is N? A union B. You can see that A union B is A, not A, B, C, D, E, F, G. Sorry, A union B. So N A union B is 6. 2, 3, 4, 5, 6. So NA plus NB. NA is 4. NB is 4. And N A union B is 6. So this is greater than 8 is greater than 6. I'll write the other way around. NA union B 6. This is 4 and this is 4. So 8 is 4 plus 4, 8. So 8 is greater than 6. So if I want to make equal this one, what I need to do? So I want to minus, because when I add these two, I made a mistake by adding this D and E. I add 2 times. When you add like this, there are 2 times D and E is counting. So A is A, B, C, D, E 4 and B is D, E, F, G. So this D, E count 2 times. That's why this is 6 and this is 8, 2 more. Then I had to take this D, E out. So N, I want to take, what is the D, E? How do you name? A intersection B. Now it is balanced. 6, 4 plus 4 minus 2. 6 equals 6. Why this time getting bigger? Because this time when you consider A, I am adding DE, and when you consider B, then again adding DE 2 times. So that error now corrected. Error is corrected by taking that 1 DE out now. Now when I divide this one, whole number of element, how many? 1, 2, 3, 4, 5, 6, 7. So likewise, that is epsilon. What is epsilon? A, B, C, D, E, F, G. So N epsilon is, N universal set is 1, 2, 3, 4, 5, 6, 7. So the sample size. So this is the sample space. Sample space. I divide all equation by total number of elements. So N A union B divided by NS equal NA divided by NS and B divided by NS minus A intersection divided by NS. So this is a number. This is a number. So this is, I can write probability of A union B equal probability of A plus probability of B of probability of A intersection B. If I explain one more time this step, uh, A union B, what are the elements? B, C, D, E, F, G. B, C, D, E, F, G. And this is equal to A. What are the element of A? A is B, C, D, E, and plus then again D, E, F, G. And you see now this is adding 2 times. So then I have to take 1 out, that is minus A intersection B. So that is D and E. So from here it will come to here, and then we divide total number of elements, and then we can make probability equation. You can bring this one to here also, right? So then P A union B plus P A intersection B equal PA plus PB. Two abnormals is one side, union and intersection, and the other one is here. I will just do it for I'm not going to prove, I will write for 3 A, B, C. So this is going to be A union B union C is A plus B plus C. Now we are adding this times to 3 times we are adding. I mean in this one, let's say A, B, C, D. From here we will get AB, and from here also we will get AB. 2 times AB, then 2 times B, D, and 2 times BC. Then I want to remove this one. So I am removing A intersection B, 1 A intersection B. So 1 BC I remove, and another AB I am removing, minus A and C, and then AB remove. Now BD remove. A intersection D. A intersection B, and sorry, A intersection B, A intersection C, then B intersection D, B intersection C. Now I remove that all repetitions, you can check. But what will happen now? I remove all there's no more B left. So because of that, I had to add one more B. It means A intersection B intersection C, this area. So when it's come to N, A, N C, N A intersection B minus N A, and N A intersection B. And when we divide by N is everything, whole total number, then it's become probability. So P A union B union C equal PA plus PB plus PC minus PA intersection B minus PA intersection C minus PB intersection C plus PA intersection B intersection C. The same way I calculated, you can calculate. Let's discuss example year 1 AS 3. Example number 3. Year 1 AX example number 3. So this is how you want to mark this one. So you have to be careful. There is a way of doing it. So in the class there are 70 students. So then they are talking about here. It is the universal set. So universal set. So we draw like this, and so this is the universal, and we write 30 here like with the bracket. Now there are two type of diagrams. Sets. One is choir, other one is school band. So choir and school band. So band. Now 7 are in the choir. Then we should not mark 7 inside. That is wrong. So we have to mark always like this with the 7 bracket. So that is total of that set. Then 5 are in school band. The same as we should not mark here. So 5 in the school band, because that 5 represent whole set. The total number of elements that set. That's why we wrote here. Now if it tells that only, then we can do it. So now in both there are 5. Uh, there are 2 people in both choir and band. Then we can simply find only choir. 7 minus 2, this is going to be 5. Then 5 minus 2, 3. Now can you see addition is 7, addition is 5. That's how you want to mark. Now when you done this one, so you want to mark, there are students, they don't play both. So then you shouldn't add 7 plus 5. That is wrong. So you should get the union. Right? Now basically when you done this one, we have how many areas here? 1, 2, 3, 4 areas. Now we completed 3 areas. So now only one area. Simple. So then what is the addition of these 3 area? 5 plus 2 plus 3. So this is going to be 10. Then total is 30. Then 30 minus 10 is 20. 30 minus this total area is 3 area 10. This is 20. Now we have the, we fill all the areas. Now you can't see any empty areas. Now we can answer the questions. The student is not in the band. So so student is not in the band. So in the band is what? B. Not in the band means B prime. So that is going to be how many? So number of students, because there are no elements. So this 5 is there, like A B, A name, A name B, name chain, and likewise there are no names, only the numbers there, the total number. So then this is NB dash. So NB dash mean, so only B is what? 5. Then 30 minus 5, 25. Or you can add this one. So these two area we don't need. Then what is the other area? 20 plus 5, 25. So then total is NS is 30. What is PB dash now? NB dash over NS. 25 over 30. So this is going to be probability as 5 over 6. Then the next question, the student is not in the choir or the band. Okay, in the band. So 2. Then C and B intersection. They are in the band. And the prime. complement. Right? How many people there? So in the band, both choir and this one, 2 people. Not in the choir or band. So in the choir is 2. Then not in 30 minus 2, 18. So then P C intersection B dash is N C intersection B dash over NS. It means 18 over, sorry, I read the question wrongly. So this is not the answer. The student not in the choir or band. So in the choir or band, A union B. A union B in the choir or band. So not mean I have to bring complement. So then this is going to be N. So how many? Not in choir and both on 20. So P, sorry, not A. This is C and B. P C union B dash is N C union B over dash over N. So this is 20 over 30, which is 2 over 3. So example number 4, it is a dog, cat and a fish. So let's have is 100 of a client. So then this is going to be 100. So this is going to be dog, cat and a fish. Then 25 on dogs. So it means dogs 25. So this is we have to put right here because that set total number of set are there. 15 15 on dogs and cats. So before that I want to tell something. In this three, if there are 3 sets, check, read and see whether you get the all the your D intersection C intersection F. So then that is the important thing first. See that 7 dog, cats and fish. 7 on dog, cat and fish. So in that case this is going to be 7. So that is the first thing actually you want to look at. And then we are starting, yes, 25. Then 15 on dogs and cats. So this is dogs and cats, 15. Already 7 is here in this one. Then 8. So it make 15. 11 on dog and fish. Dog and fish, 11. Already 7 here. So the remaining one is 4. And then uh, 10, 10 on cat and fish. So cat and fish. So this is the cat and fish. So 10. It means 7 already here. The remaining 3 I put. 40 on fish. So fish on 40. So I put on this circle. Now I can see when I look at this circle, within this circle 1, 2, 3, and 4 areas. 3 areas I know, only one area is missing. So then 25 minus these things. So 8 plus 4, 12. 12 plus 7, 19. 25 minus 19, 6. So this is 6. So that is done. Now here also I can work out 4 plus 7 plus 3 and 10, 14, 40 minus 14, 26. Now about the cats. There is another thing, 53 on cats. Then 10, 18, 53 minus 18, 35. And now all area is complete. Now this area is remaining, the outside. So outside we can look at when we add everything uh, and minus 100. So I know that this whole circle is 25. No, I will take the bigger circle. This whole circle is 53. And so 4 areas cover. Then 6 and 4, 10. And this area 26. So 9. So this is 89. So this whole area cover 89. So instead of adding 8 plus 7 plus 3 plus 35, I know this is going to be 53. Then 4 areas, then remaining 3 area I add. So that is 89. So 100 minus 89, that is going to be 11. So that 11 is here. If you want to make a probability of this one, the total number is 100 divided by 100 everything. So then it will become probability. All areas. Yeah, okay, that's fine. So now this is going to be 0.06. This is 0.08. This is 0.07. This is 0.04. This is 0.26. This is 0.03. It become probability now. 0.35. And this is 0.11. Now straight we can answer with the probability. So now dogs only. So probability of dogs only. So you can write in terms of this one, this area in terms of symbol, you can think it how to write. So you have the techniques. So you want to consider something. So you want to get the intersect D with C complement and F complement. So then, so hopefully it will should work. F union C complement intersection D. So you can look at like this, or we simply write probability of dogs only, that is 0.06. And the other one does not own fish. So own fish is uh, so own fish is when you divide by 100, this is 0.4. This is 25 the total, and this is going to be divided by 100, 53. So on fish, so on fish is 0.4. Then none on mean 1 minus probability of does not on fish, does not on fish equal 1 minus probability of does on fish. So 1 minus 0.4, that is 0.6. So otherwise we have to add everything the other area apart from this one. The same answer you will get. Does not own dog, cat or fish. So the does own dogs or cat or fish 0.07. Alright. Does not own uh, either of anything. So it means this is 0.11. Probability of does not own any type of pets is 0.11. When we complete when you complete the two also, first of all check whether you have the intersection value. That's the first thing we have to do. Discuss exercise 5b.